presentation was made by Group A for the Materials Engineering project.
In our presentation, we talk about how we find the different types of materials. We also carry different kinds of material testing to find the various properties of the given specimen. We obtain results and then use those results to find the type of material given to us with the aid of the CES software.
All materials are made up of matter. By considering density as a property, we can categorize different materials. This is easily done by using the formula of density, which is mass over volume. Mass of an object can easily be found by using a weigh scale. However, finding volume takes two methods. One of the methods of finding volume is a metric method, where we can use a linear caliper to measure the dimensions of the sample to calculate the volume. Another method of getting the volume is by using the water displacement method. Here, into a cylinder, we put water of a known volume, and then we add our specimen. The displaced amount of water is then calculated and to be known as the volume of our specimen. Once we get the volume, we then take the calculated value from the weighing scale and we put it into the formula to find density. The tensile test method is a way to find how strong a specimen is. This is done by putting a specimen under test, where opposing forces are added to two ends of the specimen and it is stretched out. First, the sample is measured in terms of its thickness, its width, and its distance. We first have to put two dots on the specimen to measure the distance of it that is being stretched. The sample is then loaded into the loading frame. Then all measurements are noted down into the computer. And as we start the experiment, the specimen is then stretched out until it is broken. Then a graph is plotted with the application running the load frame. After doing the tensile test, we are able to get a graph from the computer machine that has been connected to the main machine. This graph will allow us to find the material by giving us data that we can input into the CES software. Magnetism is another property of a material that can be tested. The material testing method includes using a magnet to discover the magnetic properties of a material. It is essential for the selection, production, and quality control of magnetic materials. The need for magnetic materials is necessary when choosing materials, including in the manufacturing of sound systems, electric motors, transformers, and sensors. Magnetism can be tested using state-of-the-art machines, in which can measure a multitude of magnetic properties. These properties include maximum and initial magnetization, saturation magnetization, remanence, and convergence field, and can create a curve for the demagnetization of a magnet on a graph for further investigation. A machine called a CNC lathe will be used to cut from the side of the material. The machine will assist in cutting the material horizontally, just to the correct dimensions for it to be tested on. Another method to find the strength of a material is a hardness test. Hardness testing involves testing the strength of a material by creating a hole in the material with a specific load in which the amount of change in depth of the hole in the material is measured. The Vickers hardness testing machine can also be used to determine the dimensions. We first place the material in the EDM wire cutter and prepare the machine by entering the dimensions of the material. Next, the machine is ready to cut the material. We place the material under the Vickers hardness testing machine with a load of 1 kilogram. The machine will then be ready to be started, which will indent the material sample. This indent is then measured by microscopic cameras, which allow the users to correctly place lines on the indent to measure the length of the indent made. These lengths will be measured through the microscopic camera as smaller if the material is stronger. Two lengths are measured with the hardness is then able to be calculated using the depth and the indent and the area created. The Vickers hardness test will allow the user to find the indent and how hard the material is and how tough the material is when a load is applied. The 3-point bend test can be done in the lab using the Intron load frame. it focuses a load in the center of a sample beam that geometrically has been entered in the computer before testing commences. The 3-point bend test measures for bending modulus and flexural strength. The test was selected to use as the results from it can be used to create a stress-strain graph where bending modulus and flexural strength modulus can be found. The 3-point bend test method is as follows. We first measure the test sample with a vernier caliper and input the results into the software. We space the supporter pins 50 mm apart and input this into the software. We set the test rate at a 10 mm per minute. We then place the test sample on top of the support pins and center it within the loading pin. Using the controls located on the Instron load frame, guide the loading pin so it slightly touches the sample. On the computer software, set the extension to 0 and balance the load, and then the test is ready to commence. After we commence with the 3-point bend test and it is concluded, the machines then input data into the computer and graphs are then given to us. An Excel sheet was produced with the results from the test using these results that you can use to calculate the stress strain of the sample at each moment during the test. By using the stress strain, you can plot a graph just like the one on the screen right now. Flexural strength can be found by finding the maximum Y value of the graph. The bending modulus can be calculated by dividing stress over strain. Yield strength can be found by using this 0.02 test, which is shown on the zoomed wire graph to the left. Using the CAS software and the properties you have found, you can narrow down as to what material the sample is. After carrying out the several tests that our group has commenced, we were able to come to a conclusion as to what material was given us for testing. We came to a conclusion that magnesium AM100A was the material that we put under test. Thank you for viewing our video.